mouse isn't working. There we go. Okay, we are on page 42 today. This is a real brain burner. It really is very doable, but it seems really weird and really hard. So what we're talking about today is when you have a set of inequalities. So solving two inequalities. You're like, why would we ever do that? So this is called a set. And it's when more than one thing is true, which probably happens to you a lot in life. So on sports teams, there's often a thing that you can be born, you have to be born by this date, but you can't be older than this. Meaning there's a range of birthdays that will work. So let's say on a team, let's say that on one team you have to, oh my goodness, you have to be at least 10 years, 6 months old, but you can't be any older than 12. Okay, meaning there is a whole range of ages that could be on that team. So if we think about, first of all, 10 years, 6 months turns into 10 and a half years. 12 years is just plain old 12. So if I'm looking at this on a number line, I hate it when I go off the line, and I'm graphing who can be on this team. People who are 8, 9 years old, they can't be on the team. Even 10-year-olds, if they're just 10, can't be on the team. 11-year-olds can be on the team. 12-year-olds can be on the team. 13-year-olds can't be on the team. Even someone who's 12 years, 1 month can't be on the team. So we're going to use a graph to show who can be on the team. So I know that 10 years, 6 months old, they have to be at least 10 years, 6 months old. So if I'm exactly 10 and a half years old, I'm allowed to be on the team. So a closed circle, because 10 and a half months old are allowed to be on the team. I can be no older than 12 years, 0 months old. So if I'm exactly 12, I'm also allowed to be on the team. So another closed circle. Now, anybody who's in between those two spots is allowed to be on the team. So this set of inequalities shows when there's more than one thing to satisfy, this is all the possible solutions of the equation, or the solutions of the inequality, sorry. Because what we have here is when we're saying if P is for player, a player has to be greater than or equal to, 10 and a half, but he has to be less than, or she has to be less than or equal to 12. So we end up with a situation where 10 and a half is less than or equal to the player who is less than or equal to 12. And this is a really powerful way to show that amount, because there's a range of possibilities in here. And if we just say you have to be 11, that's not quite true. It's yes, you can be 11, but that's not the only age you can be. So let's start with a simple one like that. If I said, you're like, simple, but if I said that B has to be greater than 15, but it also has to be less than or equal to 21. In this case, there's nothing to solve. We only have to graph. So what we're going to do is we're going to graph it just like we would have, but we're going to keep in mind that the arrow's not going to go on forever. In fact, there probably isn't going to be an arrow when you have two solutions. So keep that in mind, that there's probably not going to be an arrow. when you have two inequalities, because you're going to be saying it's from this point to this point. Sometimes there might be, but all right, so we start with our number line, and we'll start with, what do I have? We'll say this is 15. And I know that B has to be greater than 15, and it can't even be 15 exactly. So I'm going to put an open circle on 15. And I'm going to keep in mind that the shading is going to go to things that are bigger than, I should switch colors. The shading is going to go this direction, but I don't want to go crazy with my shading because I don't know how far it's going to go yet. So then I have 16, 17, 18, 19, 20, 21. I know that B either can be equal to 21 or it has to be less than 21. So since 21 is included, I can do a closed circle on 21. And now I know that my shading, if this were my only point, my shading would go this direction. So this tells me that I can put the shading in between these 2 points, and this is the set of solutions that will make this work. From 15 to 21 will work, so those things are shaded. Here's another way I can attack this. If I'm like, oh my gosh, I can draw 2 number lines. I can first, I'll do the same thing I did here. 16, 17, 18, 19, 20, 21. Okay, so I can say open circle on 15 and the arrow goes that way. And then I can say, sorry, I'm changing my mind. Close circle on 21 and the arrow goes that way. And now that I've graphed both of them on my clean number line that I didn't draw on, I can say, all right, now I know the limits of my solution. That 15 is one of the limits, 21 is the other limit, and I just need to shade in everything that was double shaded, everything that was included in both. Sometimes we might get something where they overlap. So let's say that your parents are talking to you about your allowance, and your older sister makes at least $1. Sorry, A for allowance. Your older sister says, well, I have never made more than $5 a week. So you're going to make maybe $5, but maybe less than that. Your brother says, well, I've never even made $2. And the adults at home say, well, you know what, we're going to give you, what we gave your siblings. And you're like, well, what does that mean? So in this case, if we're looking at, if they say, we're going to give you what we gave your sister. Your sister has made less than or equal to $5. 1, 2, 3, 4, 5. And since it's equal to, it's a closed circle. And all the numbers less than 5 are over here. Your brother has never even made $2. So he's going to have an open circle, and all of his shading is also going to go this way. Now, if they say, we're going to pay you the same we paid your brother and sister, this is the only chunk that applies to both brother and sister. These numbers up here only apply to the sister. So the area where they overlap would be considered the solution of both inequalities, the place where they intersect. So we're looking for overlap. We're looking for the area where the numbers are that would be true. You could take the same number and put it into both and it would be true. I'm in another room. All right, we'll pause for there and then we'll come back to this.